Okay, thank you all for joining today. Good morning, good afternoon, good evening, wherever you are. I'm really delighted to deliver this webinar in particular. I do like delivering webinars anyway, but today I'm particularly delighted as renewable energy is a personal topic of mine. Privately, I love to get involved in it. So to be able to combine my professional activities and my personal passions is really something of a treat for me. Just a quick reminder, please can you switch off your microphones and cameras, just keeps the bandwidth down, and the webinar will proceed a little bit more smoothly. I'm going to run through quickly the introduction here, and then I will focus on three areas in particular within the renewable energy space that we think we can help with. I'll touch on a couple of the other areas that we know renewable energy covers. I'll also talk about the services that we offer. And at the end, we'll do a quick summary and have time for some questions and hopefully some answers. Before we get too far, I'm just going to introduce myself, or reintroduce if you've heard or seen me before. My name is Justin McNamara. I look after our business in the United Kingdom and Ireland. I've been in the fire industry a long time. But it's been a hard graft. So, although I'm only 34, or 38 rather, I do look a bit older. I've got lots of experience broadly within the fire industry, but my focus for a large part of it has been in aspirating smoke detection technology, or ASD as it's better known for short, but also a fair amount of experience in lithium-ion battery technology and detection solutions that can really help in that space. And generally, I've got pretty broad experience across EMEA and a little bit beyond as well. And you can see my contact details there. If you need to get in touch directly with me, then obviously please do so, and then I can redirect you to one of my colleagues across the world. We're a very good, helpful team, so wherever you are, we can assist you. So what are we going to talk about today? So it's renewable energy, and I've highlighted and underlined the top three items there because they're the ones I'm going to focus on. Wind, solar, and the acronym is BESS, and that covers battery energy storage systems or plants. But I've also put four other renewable energy sources on there: hydro, biomass, wave, and tidal. And it's quite possible that our technologies can indirectly get themselves involved in those solutions, but my focus really today is on those top three: wind, solar, and BESS. So we're going to start with a kind of broad look at the renewable energy market, and I would hazard a guess that it doesn't really matter which country or continent that you hail from. The renewable energy market is sizable and growing. Now, obviously, the size is going to vary and the speed of growth is going to vary, but pretty much everywhere the story will be the same. And personally, obviously, I think that's a huge, great thing. Recently, towards the end of last year, I became a grandfather. That may be sharing a little bit too much, but I'm conscious that the planet is precious, and that if we're looking to leave it to future generations, we should take care of it now while we still have a chance. And renewable energy is going to be one, if not the main one, the main item that we should be paying attention to leave the planet in at least as good a state, if not a better one, than we found it. So renewable energy is big everywhere, but there are some challenges, as we'll see. Whichever one we choose, there are some fire, smoke detection challenges. that we can help with to keep these renewable energy sources, supplies operating. The first one I'm going to focus on is wind. And just while we're here on this particular slide, I'm going to mention design guides. So at Securiton, we're very proud of the fact that we produce design guides for the applications that we recommend our products are installed. So for wind, solar, and BESS, BESS, we've got a design guide to help you through. We've seen and been at installations, we've installed them, we've got lots of knowledge. The design guides are very useful, helpful, and indeed critical to help you and your customers, your clients, understand that we understand the challenges, we've thought about it, and we've got the right solutions. So do ask us either directly, or if you have access to our partner website, you can find design guides for all the applications that I cover, and indeed many more. But let's focus on wind specifically. And I would hazard a guess that we will all have seen wind turbines as we're walking or driving or wherever we are. We'll have seen wind turbines. Essentially, they are kind of really valuable remote assets, but potentially there is a risk of fire, and fire incidents are the second most cause of wind turbine accidents. And unfortunately, due to their very nature, wind turbines, it's very difficult to get access to them, and the ability to fight a fire within a wind turbine is limited, to say the least. And if there is an unfortunate fire incident, it's likely that it's going to be exacerbated, made worse by high airflow, potentially concentrated fuel loads. The environmental conditions within a turbine potentially are also problematic, whether it's dust, humidity, extreme temperature. They are installations, environments that really are problematic in terms of detection. So at the very least, early detection using Securiton's ASD is an absolute must. We can detect really very early, up to 1,000 times more sensitive than a typical point detector. So really at the very beginnings, the very start of a fire incident, our ASD can detect that fire at its early stage, and then in conjunction with a suppression system or other means, we can help at the very least minimize the damage, potentially avert a disaster, and also importantly either keep the wind turbine running or at least get it back up and running in a quick time, so we are able to keep our promise to provide renewable energy. You'll have seen the two main types of wind turbine, onshore perhaps being the most common. There is a picture here of a typical setup from moving from the right hand side to the left hand side. You've got some form of grid connection. There will be system protection, there will be a transformer that's probably connected to an operation and monitoring center. You'll then move through towards the actual turbine itself, very tall structure. Obviously you've got the blade on the outside, which is the thing that I think most people recall and remember when you mention a wind turbine. But inside it at the top, you've got the generator, but you also got what's called the nacelle. So that's where the generator is stored, as well as the gearbox, and that will feed down back through the cabling, back through the transformer, and all the way back to the grid. It's also not uncommon these days to have a wind turbine connected to an energy storage system. So some of that energy created by the wind turbine can be temporarily stored within the battery energy storage system for use later, perhaps when the wind isn't blowing and the turbine isn't operating. So that's a typical setup for an onshore turbine. Less common, although there's quite a few about, and more certainly I know coming in the United Kingdom, are offshore turbines. Perhaps more difficult to install, certainly more difficult to maintain, but less unsightly out there on the ocean rather than in a field somewhere. So quite popular. The setup is broadly similar, certainly in terms of the turbine. That's on the left-hand side of this picture slide. Obviously, the issue there is then we need to cable, or there is cabling from the turbine under the sea that has then got to connect back to land. But again, it's connecting back into a collector station and into the grid, and probably then connected to an onshore substation, which is its final point of connection back onto the mainland. But there are challenges there as well, not just in the turbine, as we've seen up in the nacelle and the motor of the actual turbine, but then there will be challenges, albeit onshore, but in the collector station or in the onshore substation. And it really is very important for all of us to keep these facilities, these turbines, whether on or offshore, operating. And we can do that. I would suggest strongly that aspirating smoke detection, ASD, is the right solution. The examples, 3 of them we have on the screen at the moment. The red lines are the ASD, the aspirating smoke detection pipe that will install. You can see on the far left-hand picture, we can install a pipework rising up through the tower, the actual wind turbine tower, and then across the gearbox, the generator, the electric controls, and across what's called the brake of the actual rotor blade. So we're providing very early smoke detection within a fairly tricky environment that is critical to our future. You can see in the middle section sort of more detail of a different turbine, but the same basic layout. You've got pipework running at the high point within the generator space, and then pipework running down inside the tower itself. And on the right hand side, you've got a bit more detail of the pipework within what is called, as I said, the nacelle. Very, very good solution for a wind turbine. What we shouldn't forget also within these applications is that there are other areas, whether it be cabinets, electrical cabinets, lots of cabling. They really are potentially tricky, difficult environments. So having reliable early detection via ASD is really a great solution for these tricky environments. I added this slide fairly late into my presentation just to make sure that people understand what an aspirating smoke detector is. Many of you will, so I apologize, but any harm to explain the basics. So an aspirating smoke detector, an ASD, is a very clever box which houses a powerful suction fan or an aspirator and a very clever LED smoke detector. There are 2 types shown on the left-hand side. We have a detector from our ASD 5.3 range, and then one beneath it from our ASD 2000 range, which we launched at the beginning of this year. Essentially, they're the same, as indeed are all ASDs. It is a box housing a pump, an aspirator, and a detector of some kind. Our clever detector using high-powered LED is a real step forward for sensitivity within almost any environment. We can be extremely sensitive or extremely insensitive, and one and the same within the same detection device. And simply what we do is we attach a tube or tube to these ASD boxes, and typically we will drill sample holes or attach sample hole clips to that tube, and those holes or sample clips act as the detection points. We will actively draw in the air from the area we're protecting. We will draw it back to the detector box, these boxes on the left-hand side here, and analyze what we can see. And then obviously, if we can see some smoke particles, we will trigger alarms accordingly. Very simple, but very clever technology. And as I mentioned earlier, we have two ranges currently: the brand new ASD 2000 range, which is a variety of devices, different capabilities in terms of numbers of pipe and area coverage and number of holes that we can put in. If you're unfamiliar with it, do please contact us. We can obviously guide you through the choices of the right ASD type for the right application. Similarly, our extremely well thought of ASD 53 range has been around for a few years. We have an extensive range of devices to suit all requirements, all pipe capacity issues. We have the right detection device for the right application. I'm going to switch topics a little bit, albeit still within the realm of, renewable energy, and think about solar. I know that's very close to my home, literally, and that I'm fortunate enough to have some solar panels on the roof in my home. But I also know that the Securiton head office in Switzerland has some solar panels on top of it, and we'll talk a little bit about that. I think I have a picture to show you. But solar, again, is a growing part of the renewable energy sector. Understandably, we have an enormous power source up there, way up in the sky, that is potentially providing limitless energy, and we should be enhancing that energy. And it's wherever you are, again, I think solar panels will be increasingly being installed on the rooftops of all sorts of different buildings, and it's a great source of in quotes free energy. Energy from provided by the sun is free. Obviously, the component parts which we collect that energy and the provision of it are not free, but the actual original source is free, a bit like wind. But there potentially can be problems. Fires can originate from all sorts of parts of that solar installation. The difficulty I also think with solar installations is that obviously they are external installations. They're on the tops of roofs. So it's tricky to detect any problems. Fires are often detected quite late and maybe only by chance visual observations. So early detection of potential problems is crucial, I would say critical, to keep that solar operation running. We have a solution using our D-list linear heat detection system that is robust, weather resistant, it's properly EN 54 Part 22 certified, And it's a great solution, and also requiring minimal maintenance, which for an installation that's perhaps outside on top of a building is a big plus. I mentioned that we have some solar installed in our own head office. The picture on the left-hand side here is an aerial view of parts of our building, and you can see that we actually have some solar panels there. On the right-hand side, there's other buildings. I think again, all in Switzerland. I think it's a data center and a warehouse. But you will have seen these sorts of installations in all sorts of buildings. Lots of solar panels being installed everywhere. But if we leave them alone and don't put any detection technology within them, the potential there is for, when things go wrong, for fire to start. And no detection means that it's going to get out of hand and potentially risk not just destroying the solar installation, but the building itself. The detail I expect is maybe a little bit tricky to see here, but the pictures on the left-hand side show some of our D-list linear heat cable actually running within the array of solar panels. So we're providing temperature, heat detection within those solar panel installations. And it's a tried and tested solution. We have many, many examples of this installation. You can see the picture on the right-hand side, which is, I admit, is a graphic we've sort of highlighted just to show you the type of installation that can be done. But there are many installations absolutely just like that. We install the cable at the right points to provide the temperature, heat monitoring, and with very clever installation, we can also make the maintenance, which is done from this central D-list controller here. We can make that very accessible, very safe, and dare I say it, very cost effective too. The D-list comes with, you have a controller through a connection box, and then we can run sensing cable, which we can address, so we can provide individual sensors within that cable. We can provide cable that's got sensors as narrow or as often as every meter, up to every 10 meters. And we have the ability to be able to set the temperature resolution to as low as a change of 0.1 degree centigrade. So we can be really finite. That may be a little bit too finite in a solar installation, but we can measure really fine changes in temperature. And this cable effectively, once it's installed, there is nothing that can go wrong with it. There is no maintenance required of the cable itself. It will last forever, or at least as long as the building that it's installed in lasts. So I mentioned the cable length we've got, and I'm focusing here on the what we call the SEC 15 cable. The maximum length that we could run it is 700 meters. That's an awfully long distance, covering, let's say, a solar array on a roof. And the sensor spacing, you can see there on the third line down, I can actually have these individual addressable sensors, either every meter, every 2 meters, up to 10 meters. The resolution, repeating myself, is down to 0.1 degrees centigrade. And it's a really clever, neat, reliable, cost-effective solution to keep solar panels operating as long as the sun is shining. My third highlight topic here is BESS, battery energy storage. And again, I'm delighted to be able to use our own installation as an example, there is nothing better, I think, than practicing what you preach. So within our offices in Switzerland, we have batteries. These are shown on the right-hand side here, storing the energy that we're generating from those solar panels, which is fantastic from a renewable energy perspective. But anybody who knows anything about lithium-ion batteries knows that potentially they can be problematic. Whilst they do an absolutely fantastic job in storing energy, unfortunately, the basic chemistry makeup of them potentially can lead to fire stroke catastrophic incidents. There are many examples, and I'm not going to bore you or frighten you with pictures or any examples of real incidents, but batteries, lithium-ion batteries, have been around for a while and have been studied in great detail, and there are various studies detailing some of the nastier incidents. Perhaps the best known is one actually in the United States, APS McMicken, which was a battery installation. There was several containers on a particular site, but one container in particular, the battery became overheated. It led to what's called thermal runaway, which I'll talk to in a moment, in just a single battery cell. But the batteries still continue to be powered. By the time the fire brigade arrived, the power still hadn't been shut off. And as the brigade approached this particular container, there was an explosion within the container, and it blew the doors off the container and severely injured a couple of the firefighters, throwing them quite a large distance away from the container. There's a very detailed study on it, which is publicly available. People can read it. But I kind of use that just as one example to say that whilst lithium-ion batteries are absolutely fantastic and do a great job, we have to be aware of the potential dangers of them, and particularly when there are solutions that will help us mitigate the risks. As far as BESS is concerned, we have a kind of suite of solutions that we can use or suggest be used to help keep the batteries safe. Just taking a quick step back, there are really three areas or three reasons for a battery to fail. It could be because of mechanical abuse, which I would hope in a technical, practical, professional installation is unlikely. Batteries are unlikely to be dropped or penetrated. But it is possible that batteries in that sort of instance could be suffering from electrical abuse. There might be some overcharging or over discharging or a short circuit. And it's also technically possible that they could be subject to thermal abuse if they're overheated, or in fact the reverse, if they're suffering from extreme cold. Any of those abuses could cause the battery to start to fail. And when it starts to fail, it will off gas. It will give off what are called volatile organic compounds, or VOCs for short. And then left unchecked, the battery will then move into what's called this thermal runaway, which produces smoke as part of that process. But at that point, it is too late. The battery has gone too far. Chemically, there's nothing that can be done about it. Once the battery's reached thermal runaway, it is going to continue burning until it has burnt itself out, until it's finished its job. It is impossible to stop a battery once it's in thermal runaway. Yes, we can provide suppression to mitigate damage, but the battery has got to finish the job it started. which at that point, I'm afraid, is self-destruction. This is a typical layout of a BESS, a container, but this could be a room within a building. You'll have rows of batteries, battery racks. You'll have a battery management system. You may have an inbuilt pre-supplied fire protection system. There'll be some air conditioning. This is a typical BESS layout. What I have on screen now are a number of pictures with some different solutions that should be provided, and if they're not provided at the outset with something like an energy storage container, they should be retrofitted, or if it's a fixed room within a building, they should certainly be installed. I'm going to point out, first of all, aspirating smoke detection. And again, I will stress this again before we finish, but we can help you with design and layout. But aspirating smoke detection pipes should at the very least be installed within the room space, possibly above the top of the battery racks themselves as well. You'll also notice here I have some orange boxes. These are the VOC sensors that I mentioned a moment ago, volatile organic compound sensors. So they will pick up the chemicals that are given off when a lithium-ion battery, and it doesn't matter which make or manufacturer of lithium-ion battery it is, they will all give off, in different proportions, they will give off volatile organic compounds, things like dimethyl carbonate, and lots of others, but I mentioned that just for one. These VOC sensors can pick up that emission early and potentially help prevent disaster. It's absolutely no guarantee, but they can pick up the earliest signs of battery failure before we get to thermal runaway, and there may be mitigation that we're able to adopt at that point. It's also worth in these installations making sure that we install a flammable H2 sensor as part of the installation. This is an actual live picture from our own installation in Switzerland. We have the ASD, as you'd expect, covering the battery storage room, but we've also connected an H2 sensor to the exhaust pipe. So we're drawing in air for our ASD detector to analyze for smoke, but we've added very cleverly the H2 sensor as part of that mechanical installation. It's not connected directly electrically, but mechanically we're using the air that we're drawing from that room via the ASD. We're also analyzing it for H2, which is a very neat, clever solution. There is an alternative to actually use the D list that we looked at when we were looking at solar installations. We can use D list cable also within battery racks. I make absolutely no judgment on which solution I prefer. It will be horses for courses, but it's very possible that can be a solution for these battery racks as well. I'm going to give you a tiny bit more detail on the gas sensors. On the left-hand side here, we have the spec details for the H2 sensor. The right-hand side, the VOC sensor, the volatile organic compound sensor. These are tried and tested, very clever early warning battery failure detection devices. And if you haven't come across this technology so far, you will soon. It's a very clever technology, and it's going to be a big part of all our futures, I believe. That was it in terms of looking at the actual applications. So we looked at wind, solar, and BESS. I'm going to quickly talk about extra services, and then we've got a little bit of time left for questions. So I've mentioned this a few times, but we have specific design guides to help us all with these challenges. Have a look on our website, contact us, any of the team, we can direct you into the right place, but there's no need to be fearful of these applications, these risks. We've got the knowledge, we've got the experience, and we produce the design guides to prove it. We can also, as I mentioned a few times, we can help you with designs. If you're unsure how the design should look, what the solutions should be, contact us. Respectfully, I would suggest that, you know, we are the experts. We've been through this process before. We can help with the designs. We can help with suggesting the right product for the particular application. I'm going to get on to a quick summary and do some Q&A now. But before I do that, just a quick reminder to check out our social media channels. We are particularly active, I think, on LinkedIn, but also available on Instagram and TikTok. It's well worth following us. We try to be very circumspect in what we post. It's hopefully of interest. So make sure you follow us. Very quick summary, and then I'll stop talking for a second. Renewable energy, whilst it's much needed and great, sometimes presents some really tricky smoke detection challenges, but solutions exist, whether that's aspirating, whether it's linear heat, whether it's gas sensing. We have the solutions to help. And these can be complementary to any suppression systems. Think about our design guide application library and our design services. We are here to help. And if you're looking for a partner working in this renewable energy space, I don't think you'll find a better one than Securiton. I'm going to stop talking for a minute. I'm going to have a sip of my coffee and see if there are any questions.
Justin, I've got a few questions, and the first question is, you cover solar, wind and battery energy storage systems, but isn't nuclear power considered renewable?
A good question, and I very nearly included it in the presentation. There's lots of, obviously, nuclear power stations in various countries and more being planned. Some in my own country in the UK, and we do have a lot of particularly ASD within those power stations, but technically we don't consider nuclear to be renewable because it relies on a finite fuel source, so something like uranium. But definitely it's a solution where we can use technology, particularly the ASD.
The next question, aren't battery energy storage systems containers supplied with detection systems?
It's a good question. Nearly all of them are, in my experience, but a lot of them have got very basic detection systems and maybe not always an appropriate detection system. So it's always worth checking what's installed, and then looking to see where the gaps are and how the detection can be enhanced.
The next question, how do I get help designing a system for my project?
That's really simple. Contact us. You know, one of the sales guys and girls, we're across the globe, and if you're not sure how, just contact me or contact the head office, get in contact and we'll help.
The next question, there are so many variations of ASD units. How do I determine which one is the right one for my application?
Yeah, good question. Although I give you the same answer I just gave you. Let us help. We're here to help. We've got, you know, a whole variety, as you suggested. It depends on the IP rating, the number of sample points that we have to provide, what sort of connectivity. All of that will depend which ASD we'll suggest, but you know, use our experience. It's useful and free of charge.
Then the next question is, do your gas sensors integrate directly with your ASD?
No, they don't. It's a good question. I think I did mention it. So the example I had on screen was the H2 sensor, the flammable sensor, using the exhaust on an ASD, but that I would describe as a mechanical connection. So we're just using the airflow from the ASD. We're not connecting it electrically. It's not integrated directly. That sensor would be integrated into a fire panel or a building management system or something else. We're not connecting it electrically to the ASD.
And the last question, Justin, is your linear heat delist solution that you're talking about. Is it addressable?
Yes, it is. So I mentioned it a couple of times. You can pre-order, pre-design exactly where you want the sensors, the addressable sensors, to be along the cable. Potentially every meter or up to 10 meters. You can decide how often. Obviously, there are standards that we have to adhere to, but it's also possible that we can enhance those standards and have sensors, addressable sensors, more frequently than is required under the regulations. But yes, it is very addressable.